Okay, so thank you very much for coming to the talk. So today I'd like to talk about error analysis in natural language processing. First of all, thank you for coming, and this is a treat for you. You come to here and not listening to the video or looking at the video. So this is my treat from New York. Okay. You can enjoy. Okay, so what I'm going to talk about is error analysis. And error analysis is, of course you have to do it in the research. But I conducted a project last year with many people. Not just one system on the one field, but 18 tasks joined this project. And they do a lot of error analysis. So that we can understand what's the problem in natural language processing. And also we want to learn the error analysis method. And the main topic today is about the error analysis method, because there are many error analysis results, and they conducted analysis independently. So there are many different kinds of error analysis. So we summarize it, and I'm talking about it. Okay, and as I said, trial and error is a fundamental method of solving problems, of course. But you don't want to just randomly try and find out errors. You want to be a little bit smarter. In order to efficiently achieve meaningful improvements, analysis and insight gained from the errors are essential to find a better way to approach the next trial. Okay, and this is not only me who is saying this. For example, this guy, who is a very famous inventor, Charles Kettling, says, it doesn't matter if you try and try and try again and fail. But it does matter if you try and fail to try again. Very nice English. You get? And what do you mean by fail? So this is something he said as well. And he said, we need to teach the highly educated man that it is not a disgrace to fail and that he must analyze every failure to find its cause. He must learn how to fail intelligently, for failing is one of the greatest arts in the world. So don't be afraid about failing. And you have to do he also said you can make mistake 999 times and makes one success. That's a success. Okay, so failure is good, but you have to analyze it. That's our main topic. Okay, and we conducted Project Next. So 18 groups participated. Almost 200 people participated in this. And it's conducted 1 year, ending last year. Okay, and this is the topic. So in order to make meaningful progress in NLP technologies, we believe it is crucial to conduct profound error analysis and figure out the challenge we need to solve. And that's one of the motivations. And obviously, most researchers have been conducting error analysis when they create their systems. However, it is typically restricted to an error analysis of a specific system on a specific task. At this project, we would like to conduct error analysis on many NLP tasks. And it is not only individual analysis, but across also the cross-task analysis and deep analysis of several systems on each task. So I believe not so many people have been doing this. You have lots of error analysis and find out what's the NLP technologies about right now from gathering all the results. Okay. And so, yeah, this is what I said too. Error analysis on a task correctly in order to show the direction of the task. And also relationship and dependencies among NLP tasks through error analysis. We want to understand these things. And error analysis result on multiple tasks in order to reveal common challenge common challenges needed to be solved in NLP technologies. And also, this is main topic of today, that analysis methodologies in NLP technologies. Okay, not necessarily in NLP, but you can learn something even in other fields. Okay, what error analysis really mean to us, and technology lacking in NLP tasks even beyond error analysis. These are the purpose of this project. Okay, and you can ask question at any time if you have. Okay, so how we proceed? I set up 18 NLP component tasks. I'm going to explain later. And 200 researchers joined the project. And each group conduct analysis by itself, independently. So I didn't instruct them, this is error analysis, you have to do this. But they design it, they create the data, and they figure out the procedure to do. And they have a discussion, they gather together several times and make a conclusion. And they report the results at the end of the project. Okay. And this is the 18 tasks. I know I believe many of you doesn't know NLP, so I will explain one by one. So there's a basic technologies and application layer. And this is middle layer technologies. So basic technology are the technologies you need to do some application anyway. You need this. Middle layer technologies are the technologies which may need for some tasks, may not be for other tasks. And these are applications. Okay, I will explain from the bottom. So morphological analyzer. So NLP is a technology to understand human language. You have a sentence, and for example, in case of machine translation, you translate the input to other language, from Japanese to English, Japanese to Chinese, etc. Okay, and language, in particular Japanese, doesn't have a space, Chinese as well. So we cannot figure out which is a word. Okay, and is this noun or verb or etc. So morphological analyzer understand the tokens and part of the speech of it. Okay, then syntactic analyzer try to understand the syntactic relationship between words. So this is noun, depend on the verb, etc. And predicate argument structure is a little more advanced than syntactic analysis. So for predicate like verb, which is an agent, who did what or when or something. So you want to understand structure of a relationship between predicate and phrase, noun phrase, etc. Okay, and some middle layer technologies are needed for some applications, and NE, named entity, is a technology to understand names. Not just nouns, but this is name, like Japan, I don't know, person name, location name, organization names are very important to understand the sentence or text. So this is technology to understand names in text. And coreference is a technology to figure out pronouns. So it or he, etc. And he refer to what? For example, John kills Smith. He was arrested. What does he refer to? Maybe in this case, John. Okay. And in order to do all of this, you have to have a knowledge about language. And we try to get this kind of knowledge from corpus or web text or something like that. You can use dictionary, but dictionary doesn't cover all. And right now we have a lot of text on the web, so we try to understand the language knowledge about language from big corpus. We call it the text. So there's a technology like for that purpose. And the paraphrase is another technology, very semantic field areas. So paraphrase is very crucial in language. You can say the same thing in different way. For example, I wrote the book X, or he's a author of the book X. That means the same thing. But unless you understand this, you cannot really understand the meanings. So this is the technology to understand this. And what's word sense disambiguation? That's the opposite of paraphrase. Language is very flexible. The same word can mean several things, like bank, example. Bank can mean the financial institute, but also it means the area along the river. That's also bank. So if you say, I walk along bank, you are talking about maybe the river, the area near the river. But I went to the bank, it's more likely to go to the financial institute. So we have to disambiguate these semantics in order to really understand the text. Okay, so these are the technologies, basic technology. It itself cannot be application, but these are technology we need to conduct the applications. We need to create applications. Okay, and there are many applications, not only this, but there are many. But these are typical applications we are actually working on, mostly. So information retrieval is search, basically. You have a query, and you try to find the text or web page which match to the query. It's called information retrieval. Usually people say search right now. And the summarization is, as it says, a summary. Create a summary from the long text. You don't want to read all the text. You want to have an important part of the text. So it's called summarization, automatic summarization. And information extraction, this is IE, is application to extract very important information in the text. For example, from newspaper, you want to understand who did what, when, and where. If there is some accident, you want to know what happens and who did what, where, and when. These are the important information for that. So automatically extract this information. That's called information extraction. Okay, and the review analysis. So right now there are lots of reviews in the web, and this is very important for merchants or the web e-commerce or something like that. So review. So by reading the reviews, like tweets or actual review, etc., you want to know what people are saying about my product. They are positive or negative, or they like this aspect of this product, etc. So that's important, and this is technology to do that. And web application, this is very general, and lots of web application in NLP right now, because most of the information is written in natural language, and we as a human, it's easy to understand, but for machine, it's not so easy. But because the text is so huge, so big, people cannot read all the text. So try to automatize this, try to make it automatic, is what we are doing. So there are many web applications. So one of them is like an analysis of Twitter. For example, right now it's very cold, and people taking a cold, having a cold, coughing, and have a fever. Maybe we want to understand, or maybe the people in this area has a lot of cold right now from Twitter. And if we can do it automatically, that's nice. Maybe the medicine companies want to know this kind of information. Okay, we should sell lots of medicine in this area. So that's one of the applications, web applications. Okay, and another application is Tokyo University robot. I don't know, maybe you may heard this. So people are trying to create artificial intelligent robot which takes the exam, the university entrance exam, and they want to know if they can pass the Tokyo University. Right now, they said that they can enter 70% of university in Japan from their results. Tokyo University is very, very difficult, so they are not yet that level, but they are getting smarter and smarter. Okay, and the machine translation. So this is, people know that, even you can use this Google machine translation, etc. So maybe some of you are using it. So this is very difficult problem. Still, between Japanese and English, we don't see any satisfying results yet. So people are working on this right now. Okay, and other applications include Japanese proofreading. So people write Japanese and try to see some mistakes in this text and etc. And English as well. And finally, there's a dialogue program. So it's like a Siri. You can talk with the machine and keep the dialogue. It's not easy, as you may try Siri, but that's why we are working on this task. Okay, so these are the tasks of NLP. Yeah, it's typical, very popular tasks people are working on. And we ask the people who is working on this to do error analysis. 18 different groups. And that's what I'm going to talk today. Okay? Understand the NLP tasks? So this is what we did. So in March 2014, we had a workshop in a natural language processing conference. And we have a discussion about data analysis, error analysis, etc. And we decide, let's do it together. So this was very, very nice workshop. And people have the feeling together, this is the way to go. So that's why 200 people participated in this. And May, we had kickoff meetings and midterm meetings. Many people came to this meeting too. And they set the report. And the final reporting meeting was conducted on March 2015, just 1 year ago, in Kyoto University. So people found, this is interesting. So I was invited to write or edit some special issues of natural language processing, information processing society, and the AI societies. So if you can read Japanese, I'm sorry, all of this is written in Japanese, but you can find the detail of this project from these publications. Okay. Yeah, not only publications, but there are homepage, a little bit of English page about introduction, and all the papers are available from the web. And this is the final workshop, and these are the special issues of this workshop. So that could be fun. Okay, so that's the introduction. Clear? Yeah? Yeah? Okay, thank you. Okay, so then I'm going to go to these methodologies of error analysis. So there are 18 groups who did error analysis. Actually, there are several groups which did several different error analysis. So maybe there are 25 error analysis. And I categorize them, I look at them and categorize them, and it was categorized like this. So, you can say error analysis, but there are many ways to do it. So this may give you some insight, not necessarily NLP, but for other areas as well. Okay, so that's the main topic today. Okay, first I'm going to talk about these 3 topics: task analysis, data analysis, and system analysis. So if you say error analysis, many people think, okay, you can run system and find out the errors and categorize them or etc. But actually people did more than that. So the main result is system analysis, but people go back a little bit. They think about what is the task? What's I'm doing this? No, this topic. What kind of task is this, etc. And also they create the data and they analyze the data. So there's three main categories of analysis, and we will go the detail later. But these three are the ones like this. So first, task analysis. They try to analyze the task. Okay, analyze the task. It's very vague. What does it mean? They analyze the task based on the problems. You know, each task has a different kinds of problems. They list up them and they analyze the problems. Okay. There are instances later, examples in the talk, but you can just grab the overview. Okay. And also you can analyze a task based on technologies. What kind of technologies they use to solve this problem, solve this task. And also subtasks. Some tasks consist of several tasks. So understanding subtasks, understand this task. Okay. And this method, task analysis, was done for the task which hasn't been well studied yet. So for example, morphological analyzer, people have been studying this for 20 years, 30 years. So they know what is the problem, what is the task. So people are not likely to do this because they know the task. They do a little more difficult system analysis. But if the task is new, they have to understand what is the task. So people tend to do this task analysis. Okay, and the data analysis is create the data on the aspect of the task. So people who is doing this are the people who want to see different point of view on the task they are working on. Okay, they have been working on this for 10 years, but they want to see a little different aspect of this. So they create that data for different way, different directions. So that's interesting. And finally, the system analysis. So run a system and analyze error. This is very typical. Maybe 80% of the people did this. And this was done by the people whose task is matured. Okay. If there are many systems on this task, they run it and they want to understand the errors. Okay. Okay, so I'll go one by one. First, task analysis. I'm going to talk about task analysis. So, and this is task analysis based on the programs. Okay, so the first example is about from the English proofreading. The English proofreading is a system to identify the errors of English sentences. Maybe I write or somebody write. And in this case, maybe this is English proofreading for Japanese writers. So Japanese writers make mistakes in article. No, this is very difficult for Japanese and Chinese maybe too. Or noun numbers. There's no number in Japanese, so people are making mistakes. And preposition, tense, noun selection, verb selection. So this is analysis of the problems. People want to know where to tackle. Okay, this is a problem, then they want to create a system to identify the appropriate article. Right? And this has been done. Of course, the English proofreading system exists like 20 years. But the problem is that the English itself are different. If you are Japanese or Chinese or German people, different kinds of mistakes they make. Or the text is, for example, patent or business domain or scientific domain, the mistakes are different. So they want to understand what are the problems they have to tackle. I don't remember exactly what's the text, but this is obviously Japanese people writing English. Maybe the English native, so there is an English proofreading for English native as well that may have a different kind of distribution. Right? So analyzing this kind of things is very, very important. Okay, and paraphrase group. So paraphrase is the same meaning, different expression kind of problem. So what is a phenomena of paraphrase? There are changes in post position, there is omission, etc. Voice change, active voice and passive voice. So they try to understand what is a problem in paraphrase. Okay.
Could you explain the meaning of this number?
Are these numbers?
Yes.
Okay, they I think they extract the paraphrase from some text, maybe I think 100 example, and these are the number of example which has this problem. So 33 example has a post position changes, and 24 has omission. So this indicates the importance of the problem. Okay, thank you.
I also have a question about the first one.
Uh-huh.
Professor, you just mentioned that the result of this distribution is very important. But according to my experience, when I input something like Word, it just corrects for me, and I don't see the importance of knowing which kind of mistake I made. So maybe it's enough for the computer just correct for us.
Yeah.
So what is the importance of
Okay.
knowing
Good question.
the distribution?
So there's a system which corrects your English right now, but it's not just automatic, right? Somebody created this system. So I don't know how many times you make mistake in article or spelling, etc. But if you keep making mistake in article, the system has to have that kind of function. Right. So yeah, it's nice if the system corrects your English 100%, but there's no system which can do this right now.
But if you use like Microsoft Office, if you input something in English or in Japanese, and they will check if there is any syntactic error or some other thing, and they will ask you, would you like to correct like this?
Mm-hmm. Mm-hmm. Yeah.
So, yes, I think really that is enough for us.
That is
Enough.
enough. Oh, you feel it's enough? I don't think the office is enough for me. So that's why the people working on this.
Okay.
Yeah, maybe office is good for the business domain, etc. But maybe it doesn't good for, I don't know, patent, for example, or I don't think they can correct the article perfectly. Right. Okay. Thank you. Oh, thank you. Yeah, please ask a question like that. Okay, and next one is the task analysis based on the technology. So this is people working on knowledge acquisition, and they select this task, Winograd schema challenges. This is a international competition kind of project, and they want to understand actually co-reference. So if there's a sentence like, when Debbie splashed Tina, she got wet. This she refer to Tina. Right? When Debbie splashed Tina, she got in trouble. No? This she means Debbie. Okay. People understand this, but machine can't. Machine, at least very difficult. Okay. And in order to solve this problem, what kind of knowledge the system needs? That's the analysis of what they did. Okay, and they found out again. They select, I don't know, 90 examples, something like that. And they try to understand what kind of knowledge they need. The first one is selectional preference. Selectional preference is knowledge which try to understand, for example, people can eat or animal can eat, but not the book can eat. That's a selectional preference. This can solve lots of problems like this. For example, if sentence is like, dog ate banana, or chimpanzee ate banana, and it was rotten. Dog cannot rotten, but banana can rotten. So the selectional preference can solve this problem. And in this case, knowledge about event. So this, I think, this is meta knowledge or common sense. No, if somebody splashed somebody, and somebody got wet, because splash and wet relationship is from the common knowledge. So we need lots of knowledge, and we try to categorize them. And if we understand this, then we can focus on the knowledge we have to create. Okay. Okay, and the final one on the task analysis is the subtasks. So this is a paraphrase. So paraphrase is relatively new. Maybe 10 years ago, they start understanding, oh, this is important. So there's not so much data yet. And they don't know how to collect the data appropriately. So paraphrase, if you want to do research on paraphrase, first thing you have to do is data collection and categorization. You know, there are several data, but it's not really perfect yet. And analyzing the instance is the next thing. If you get data and develop the data and technologies, in this case, data is not the instance of the paraphrase, but the data in order to solve this problem, and technology to solve this problem. And the paraphrase recognition. So you want to understand this phrase and this phrase are paraphrase. For example, in order to search, do the search, you search like author of X. If the sentence says X wrote this book, no. Right now, the Google can, maybe Google do this research too, so they can understand this, but it's not perfect. So we want to find out, we want to recognize the paraphrase. And also paraphrase generation. That can be used, for example, if you want to translate the sentence into easy sentence. No, the same meaning, but it's easier, so that, for example, elderly people can understand this, or the foreign language learners can understand this. So we need a generation of paraphrase. Okay, and lots of other applications using paraphrase technologies must be there, and they want to do this. So they categorized, list up the subtasks like this. Okay, that's another way to understand the task. Okay, so that's the task analysis. Okay, the next one is data analysis. Okay, so there I list up two examples. The one of them is dialogue. So there's a system like Siri. You can talk with the machine or AI, but sometimes they say something weird. No, maybe you have experience like this with Siri too. We call that is a breakdown, and they focus on this breakdown, what's happening and why it's happened, etc. Because the dialogue system as a whole is too complicated to analyze. So they try to understand this one aspect of the task. Okay. And they actually run a single dialogue system and ask human to judge if the dialogue has a breakdown or not. Then they analyze it. And in terms of the agreements by annotators, and categorize the type of breakdowns. So first, they create a system or the interface like this. This is the conversation with machine. You know? The color part is created by a system. And they ask people if there's a breakdown or not. maybe the circle part is not breakdown. The triangle one is maybe the axis. It is breakdown, etc. Okay, and they asked 20 people to do this and see the agreements, and they can leave the comments as well. Okay, and this is this is analysis of the results. So they found out lots. I think that 20% of the utterance are breakdowns. So smart, it's not smart yet. And they try to find out why they think it's breakdown. Maybe grammar is error. So system make ungrammatical utterance. So this is breakdown. Or semantic errors, or inappropriate, etc. So they categorize the reason of breakdowns. And the biggest one is out of context. So they say something out of blue, something completely new, and they are not understanding me. So that's breakdown. Okay, then we understand, and what we have to do next. That's the reason of this error analysis. Okay, I don't go into this detail. I'm just organizer of this whole project, and I'm not doing this research. But if you are interested in, there are lots of papers about this, and you can read it. But I can answer if you have some question. I can try at least. Okay. Okay, and another data analysis is kana kanji conversion on Twitter input. So this is morphological analyzer task. So people, Japanese people using this keyboard to input Japanese sentences, and most of the time they use morphological analyzer. So this is word, and word changed to kanji expression. And so let people use this system and try to understand where they go back and replace it, etc. So these are the mistakes actually. So so this is the results, and because this is a Twitter input, it's the distribution of the errors or the topic, the problems are different from the ordinal text, like newspaper. For example, long vowels and small case character, the small a or e, etc. These are found, and the emoticons, so the face or something like that, and lots of proper nouns, and the insertion errors, etc. So if you want to create a new morphological analyzer, these are the things you want to pay attention to. Okay. Okay. Any questions? Fine. I was asked to make a break in the middle. I think this is a good timing to make a break.